everyone once again. My name is Piotr Szkoda from Virtus Lab, and with me today are Mikołaj Kromka and Wojciech Nowak. So Virtus Lab, with its 12 years of experience, is a strong partner in software development and has key expertise in diverse areas such as custom software development, including what is related to data platforms. This is why we're gathered here today to share our knowledge with you, and I'm really delighted that so many are attending today's webinar. How important is data modeling in modern big data platforms? Maybe a few more words on organizational matters. The Q&A will be at the end of the webinar, where we will answer your questions. So please write your questions in the Q&A chat. So there is a section here on the Zoom. I think in the panel on the right-hand side, you will be able to open the chat. So 3 dots, and then you will put more and the chat. Not the chat, but the Q&A section. So 3 dots in Zoom application and then Q&A section. If there are a lot of questions, more than we can answer in the limited time available, or if someone is simply not willing to ask a question in public, you can find our presenters on LinkedIn, and you can reach them directly there as well. Okay, so without further ado, Mikołaj and Wojciech, could you introduce our audience to what's on today?
Hello, everybody. My name is Wojciech Nowak, and together with Mikołaj, like Piotr just have said, we have this pleasure to present you our thoughts on data modeling and its role in building modern, robust end-to-end data solutions. Exactly like Piotr said, we are from Virtus Lab, the company that delivers software solutions for most demanding clients worldwide. And at the beginning of the data system, the technology was not mature enough to generate the performance boost from the hardware. The cost of compute and storage was high. That's why the companies started thinking about getting desired output in different way. And this was the time when data modeling techniques have arisen. The data systems were built upon RDBMS, and the way of structuring the data was the key factor that could bring a lot of benefits to the system. For example, data modeling could improve application performance on increased consistency in the data system. Moreover, modeling techniques could cut the costs of development and maintenance of an application. These were the times when the division of data system have happened. And depending on the demands which platform needs to fulfill, we can differentiate OLTP systems and OLAP systems. OLTP systems tackles day-to-day operational data and are optimized for updates, inserts, and deletes, whereas OLAP systems support decision-making and are read-optimized. Traditional warehouses adjust schema on writing the data into the system. In this phase, different modeling techniques can be employed. For example, 3NF, modeling cube, data vault technique, or Kimball's approach. The last two are the most popular techniques in data warehousing nowadays. Kimball's approach could, for example, provide a good performance boost while processing analytical queries, while Data Vault ensures flexibility, provides organization-wide model, and have unique auditing capabilities. Even though the both techniques have been published over 20 years ago, they didn't get old and still are widely used in modern warehousing solutions. Traditional data warehouses plays important role in data industry. They feed reports and charts, and way of presenting information is crucial for many businesses. However, the techniques didn't change, although data landscape have changed. And traditional data warehouses, which are expensive, which are hosted on on-prem environments, which are rigid and inflexible, are passing away. The rise of technology, especially in the first decade of the 21st century, caused the rise of semi and unstructured data. Data like camera feeds, like unstructured text or graphs, are used in many use cases. For example, modern one like machine learning. All of this caused the necessity of finding a solution which will be able to store, ingest, process, and publish all the data from all the sources, regardless their type. And that's how data lake solutions have arisen. And data lakes are able to store all types of data. When the data gets into the data lake system, it is saved in an unchanged form, and the structure of the schema is adjusted on read in form which depends on the needs. Along with those data lake architecture systems, solutions which are widely known for every data engineers now, like Spark, like Parquet, like Hadoop, Impala, have gained a lot of popularity and appeared on the market. However, the platforms which employ data lake solutions and data lake architecture are centralized. As it has been said, they are just schema on read and are composed of different data pipelines. Such approach fulfilled the need of handling all types of data. However, data engineering team, which owns the platform, has become the bottleneck. The necessity of supporting all the data platform pipelines within the platform makes the data engineers constant firefighting and fixing leaks in the pipelines. Such duties take most of their time, so they cannot focus on technical depth, or they cannot focus on the data and taking care of the data. What is more important? The platform, which is built based on this architecture, doesn't scale well, doesn't deliver promised value, and makes all of these stakeholders frustrated. And since current approach for data platforms doesn't fully work, the new solution needs to be introduced. Addressing the problems of the past and present, and synthesizing those problems with the solutions that have worked and have been present throughout the evolution of data system, we can have a few conclusions. For example, we can say the modern data platform should have standardized data ops practices to minimize the time spent on operations by data engineers, or we can say that the platform should embrace the metadata and to have deep insight into the platform. And different people across the data industry came to similar conclusions. Some of them have shared their opinions in this area, and they have provided tips, solutions, and approaches which they believe will be part of the data platforms of the future. There are at least few of them that are worth to be mentioned. For example, one of them is the database approach for data architecture, which can be characterized as a distributed microservices-like architecture. In this approach, the control and ownership over data is in the source team. Domain-oriented source team needs to share high-quality data, well-documented data, which meets agreed service level agreements. In this architecture, the data teams are built of T-shaped engineers, and each of them have different specialization. This allows the teams to achieve synergy and deliver high-quality products and meet the demand of the stakeholders. Yet another solution, which is worth to be considered, is data lakehouse. Main proposal of authors of this concept is the creation of the metadata layer over the lakehouse. It can automate and support different aspects of data platform, especially operation and the ones related to data quality, versioning, etc. It can be done by providing additionally the stakeholders could join the data and metadata together and gain a boost in data understanding. In the data industry, there are also some solutions which are present since the beginning of data platforms. They never get old, and its usage in the project always paid off. First of them is layering, which means that the data platform is built from layers. Each layer has different purpose, but it can be said that each subsequent layer holds the data which are more adapted to the end user. And finally, there is a modeling about which we've been talking and could bring a lot of benefits to our systems. There are lots of challenges in front of people who want to get involved into data industry and build robust production-grade data platforms. The ones related to warehouses have been already shared in this webinar. The ones which refer to unstructured data and machine learning use cases will be described by Mikołaj Kropka now. Mikołaj, feel free to continue.
Thank you, Wojciech. So does it end there? Does Data Lakehouse, has it all covered when it comes to data storage and processing? Yes, but the things get much trickier if we try to do some advanced analytics or data science. Let's first see how the typical data science pipeline looks like. We are going to use an example of a supervised learning pipeline. Data first needs to be transformed into a set of features and labels. These features are then consumed by the model during training. Then this trained model can be used to predict new values. Although the model sometimes can be stored as data, for example, weights and number of neurons in each layer of neural network, it's typically a serialized code with some config. Features, on the other hand, are mostly data of specific shape with some metadata attached to them. But for prediction, you need features for entities that are not present in your training dataset. And what is more important, the new data can come from a different data source or sometimes even have a different shape, which means that choosing the shape of the feature is in essence similar to the typical data modeling in a data warehouse. Here we have an example of a training set for a prediction problem. We want to predict a price of a house. The data set consists of features, in this case, columns such as district or number of bedrooms, and labels, which are the values that we want to predict based on the features. In this case, price of a house. Thankfully, the shape of data is typically defined by the ML model. It can be a data frame, a time series, or something more custom. But since the features can be reused across different models and projects, it's critical to store them in a well-defined format with corresponding metadata, such as version, creation time, lineage, and many others. Since features and metadata are central to all data science operations, most machine learning platforms have a component called feature store. It acts as a central source of data for all operations on model, such as training or serving. Not all components, of course, from this diagram are always needed. There are different ways of characterizing feature stores. If you need to serve your predictions in real time, you need to have features available quickly. You won't be able to process terabytes of data when user is loading your website. This is where online feature stores are used. Data they serve are small and available through some form of an API with a low latency storage, such as key value stores. And personalized recommendations on websites or anomaly detection in machines are some of the examples. On the other hand, if your model needs large volumes of data, which is typical during the training phase, or if you don't need your predictions available in real time, then you can use an offline feature store. Data can be stored in a storage like S3 or HDFS, which are better suited for handling large data sets. And the typical example are daily forecasts. Another way of characterizing feature stores is looking at what they store. If you need to only have a storage of the feature data, you can use the literal data store. One of the examples in the market is Feast. On the other hand, if you want to be able to pre-process your data, for example, to recalculate some of the features on the fly, then apart from storing actual features, you may store and be able to execute the code used to generate them. This is done by the physical feature store. And one of the examples on the market is Zipline from Airbnb, Drift from Lyft, and Michelangelo from Uber. And something in the middle, if you want to store feature data and manage computation, but you don't want to be responsible for executing them, you could use the virtual feature store. Feature calculations are delegated to your existing infrastructure. It can be seen more like a workflow. And the main example from the market is Featureform. Feature stores are typically yet another layer of data in modern data platforms. That area is developing quite rapidly, but there are still some challenges. Some of them are just technical, like storing proper metadata or access control, but most of them seem to be related to people. Feature stores are just tools, and if used in wrong hands, can lead to a data chaos. Picture of hundreds of features that are not managed, not used, have no metadata, is common and similar to what happens in data platforms with more traditional tables and datasets. Features, which are critical data, are modeled by data scientists. This makes them de facto data modelers. Similar causes led to the rise of data architects and data architecture in general. So does it mean that to avoid data chaos, we need a new feature architect role? Well, from one side, it makes sense because we want to easily reuse the features across the platform and across the company. But advantage of data science was flexibility in creating data models depending on their needs. See how that works in case of notebooks. Data scientists for research purposes use notebooks and create lots of temporary models. Adding to the fact that some of the models can be implicit, for example, by using dynamically typed languages such as Python, it's unclear what is the schema of the data in each part of the workflow. If this code is used to generate production features, which happens many times, many bugs can be invisible for a long, long time. And this is just a part of wider challenge with the self-served approach. At Virtus Lab, we are strongly devoted to self-served tools and frameworks to avoid duplication of responsibility. Enabling data scientists or analysts to create machine learning or data models in production themselves save lots of time and money. But the self-served must always be accompanied by traditional software engineering best practices, such as versioning, code reviews, testing, metadata storage. Not all tools allow that. The answer to this issue is data hygiene and foundation training. To summarize, traditional data modeling techniques are still relevant in modern data platforms. But the amount of unstructured data is growing and is growing rapidly and will be growing rapidly in the future. Centralized data lakes are not a solution because they are costly to maintain in the long run. In the context of machine learning, feature stores are modern machine learning data warehouses. But unfortunately, lots of effort is put into technical aspects of those feature stores, not in the feature modeling itself. Most of the data platform challenges seem not related to the tools because we have lots of tools that we can use, that you can buy. They are related to people and processes. Self-serve tools can save time and money, but they need to be accompanied by best practices from software engineering, such as versioning, such as metadata storage and code reviews or unit tests. And lastly, the more modern data platform is, the more focus needs to be put into the skill set of people creating this platform. Data modeling skills are critical not only for data modelers, but for engineers and for data scientists as well. So what we see happening in data science right now has happened in data warehousing some time ago. We predict that data modeling and especially feature modeling will become much more important in the future. Thank you for that. And now is the time for Q&A.
So thank you, Mikołaj. Thank you, Wojciech, for this insightful information. So let's move to the Q&A part right now. Just a reminder, so in the panel at the bottom, you can see Q&A section. So if you haven't submitted an inquiry yet, you can do this right now. So I've seen already there is a bunch of questions. So let's go through them one by one. And by the way, if you have any questions, right, that was not submitted yet, you can also ask them live during the Q&A. So raise your hand at the end. But let's go maybe first with the questions which are already in the Q&A section. So first question we've got from Mariusz. How do you think good practices from software engineering should be introduced into the team?
Well, that's a good question. Definitely from my side, from my experience, versioning, code reviews, and unit tests. This is something that is not popular across data modelers, business analysts, or data scientists. But it's critical for the data platform to be working correctly. Because if you, especially in the self-serve environments where data analysts or data scientists can create the production pipelines themselves, when they do that, they de facto create a production code, a code which is running in production. But sometimes, many of the times, it's not reviewed, it's not tested. They just quickly skim through the results because they have no knowledge about it. So yeah, I think those three are the most important ones.
There's one more things that come into my mind. The pair programming, the practice which is highly underestimated, not only in data, but also in software engineering. But it could cause the quality boost. And yeah, what do you think, Mikołaj?
Yeah, definitely. Pair programming can work in any IT department, I think.
Thank you. So I hope, Mariusz, you're satisfied with the answer. So let's go further. The next question is from Grzegorz. So where do you see the role of custom software solutions in model data platforms?
That's a really good question because we've been talking a bit about that data mesh, and this is approach for mainly focused on taking care of data quality, but also distributed approach for data tool having self-served, loosely coupled platforms or tools could work in the data. So decentralization, not only in organization, but also on architectural level, having different types of tools, which are integrated but relatively loosely, could prevent lots of maintenance and getting legacy issues.
And I think to add to that, I think the question you need to answer as a data platform owner yourself is, where do you see your competitive advantage? Because if you buy just the tools that are available on the market, then you'll be as good as other competitors that have those tools. So if you have a one place where you really need this competitive advantage, then consider a custom solution to be used in this place. But as Wojciech said, I think that loosely coupled but highly aligned, this is popular in IT. This approach to data platforms should be is the best.
Thanks, guys. The next question we have is from Tomasz. What kind of modeling do you expect for unstructured data like videos or images?
Yeah, okay, this is a good question because it's easy to model data if you have relational tables, right? You create just different tables, you have some foreign keys and stuff like this. In case of I don't like the name unstructured data because every data has some structure. Sometimes it's implicit or invisible. But when it comes to things like videos or images, The most important part to maintain them in your data platform is the metadata, of course. So metadata is really critical. So all of the features, all of the metadata about this image or video, like resolution, like the length, stuff like this is a simple stuff. But of course you can also think about more complex cases. Typically, when you process video or images, you do lots of mathematical calculations, like matrix decomposition, and those mathematical calculations result in a set of vectors, numerical vectors, and they are de facto the model of what we want to store in our data platform alongside with the original data. Secondly, you need to think about how this can be reused by other teams. Is my way of decomposing the data, can it be reproduced by other team with all of the data that is available in my data platform? So yeah, I think those things are something that you need to answer.
The next question we have is from Michał. What are the best practices for storing metadata of features in your opinion?
Well, that's a good point. There are different data catalogs available on the market itself. Metadata needs to be stored every time you do something with the data. I worked with different projects. Either those could be stored in external tool like like Atacama or different data catalogs. But you can also create a custom solution for storing your metadata depending on your needs. For example, in one of my projects, we are storing the metadata on S3 as JSON files with a loose schema.
Yeah, what is worth to add? Some meta model could be created for storing metadata, and based on this, we could build. Actually, the storing metadata this way open up different capabilities to build robust data solutions. One more thing which might be worth to add is use the storage itself. For example, you're working on some kind of a storage solution to store the metadata like the Kafka does.
Thanks, guys. We've got also two questions from Paul Young. I apologize if I'm saying the name incorrectly. But the first question is, when dealing with data, when is versioning important? I mean, data versioning.
Well, I think from the start, because what is typical in data platforms is that the shape of the data that you ingest or you transform changes all the time. So the same data set in a couple months can have a completely different, even though it's from domain point of view, it's exactly the same. It can have a different shape. And you are unable to reuse old partitions. So versioning should be used when you first introduce the data into your data platform. Then, of course, if you have multiple layers in your data platform, then versioning still needs to keep up with that. Let's say I create some files from my Spark jobs that need to be read by a different team. And when I have a breaking change in the schema, then I need to bump the version so that they know this is something different, and that those two versions are incompatible, most probably. Sometimes you can if your changes are backwards compatible, then this version bumping is, of course, not needed, not necessary, depending on the tool that you're using. But still, keeping the version is important almost for every data set that you have in your platform.
One more remark, which is indirectly connected with your question, is that we can also version the transformations, which have also indirect, but still has some influence on the data or on the further layers, right? So this thing is forgotten, and underestimated, but still we should remember that not only data can be versioned, but things like transformations and others also can. Transformation notebooks, Jupyter notebooks, some pieces of code, custom SQL stuff, etc.
Although just one thing to add, for the research purposes, it's not always useful to have this versioning. I would say that when you productionize your tool, then this is a place where you can start versioning, because even though notebooks are really useful, then not all of the models that data scientists create, for example, are needed to be stored.
Yeah, so in this case, data notebook catalog would work, or solutions like that.
Sure. But I'm not sure what you had in mind, say, writing data evolution, but I do believe that your query was somehow answered in a way. And when going further, so the next query from your side is, considering that the amount and expectation from data varies from organization to organization, when should or what type of organizations should be concerned about modern data practices / tools? So Mikołaj or Wojciech, you just take a look at this question, try to answer this one.
So if I understand, when do you, as a data company, what size or what volume of data, or what size of the data platform is considered something that needs to be taken care of more meticulously, right? I think this is how I understand it. Yeah, I'm just reading it. And expectation from data varies from organization to organization. Should concern about modern data practices. Well, it depends. I think it's a hard question, because of course, if you have a startup where you are just looking for a result, and you are doing lots of things that are not necessarily that will be necessarily used in the future, then you of course don't need to have all of those heavy processes. But if your organization is larger, what does it mean larger? I would say like hundreds of people. Maybe the number of people is not so important, but the number of use cases, how much data driven is your company? Because if you just store the data and don't use them, then all of the best practices are not so necessary. If you use your data daily to decide on different things, if you have some automated processes where which are based on the data that you automatically feed into your data platform, then this is something definitely you need to take care of.
Yeah, exactly. And for the bigger organization, the easiest solution is to develop data lake which is centralized. However, as it has been told, it generates lots of problems and some frustrations among engineers who need to support it. I'm sure that if you were an engineer or are an engineer or is an engineer, then you totally understand what I want to say. And the process of evolution of those centralized data platform is not an easy stuff. It requires deep analysis for sure, open-minded people, and also some knowledge and having direction towards what is the final goal, right? And the one thing in such case that could be fixed and could improve the well-being, not only well-being of engineers, but also the final output and speed of delivery, but the speed of value delivery would be the data ops practices. What do you think, Mikołaj?
Yeah, I think it makes sense, but I also have one other point on that, because I agree with you, and if you build your platform in such a way as we described, so you have a loosely coupled but highly aligned set of tools rather than one huge monolithic platform, then it's much easier to replace each part. So if you grow, if you follow this this architecture, then if you see that some parts, for example, you have not enough metadata or you can't store the metadata easily, then you can just replace this one tool, or you can create something on your own. So I think this is something to consider as well. So if you create the platform as loosely coupled but highly aligned set of components, then regardless of the size, it's much easier for you to work with such data platform in the long run.
Yeah, and it's easier to avoid vendor locking, right? While having like one big solution from for one company, it is easy to lock itself and like have some issues with further migration or different processes.
Yeah, or just cost, right? Like exactly like with Oracle, right? The JDK a couple years ago, the differences in licensing, right? So
exactly.
Everybody used, maybe not everybody, but lots of people use Oracle JDK. Now OpenJDK, I think is maybe not most popular, but it's really popular. Similarly, recently in the Scala ecosystem with Akka, exactly. They started licensing Akka. And right now, if you have a huge platform built on Akka, then you need to pay lots of money. But if you have it as this is not analytical data platform, but if you have your Akka platform as a set of separate services, microservices, then it's easy for you to replace each component separately.
Thank you guys for answering all the questions. I see not a question, so thanks everyone for submitting and answering the questions. And first of all, thanks for your participation in the short webinar. It was recorded, so if you'd like to watch it again, we'll definitely send you the link later. At the same time, we'd like to invite you also to take part in our survey about this webinar. The form has been already published in the Q&A section, so you can keep us your feedback. I believe it will be shared also in the email communication. So if you have any questions relating to software engineering, what we do, feel free to contact us anytime, for example, even via LinkedIn. So thank you for your time, and I hope to hear from you again, unless there are any last-minute questions from anyone. If there are other questions, so thank you very much, and have a nice rest of the day. Thank you.
Thank you.
It was a pleasure.
Bye.